figure shows the railway overhead conductor for current collection by pantograph system. The cantilever is fixed on the mast. The bottom portion is called bottom insulator with bottom attachment and bracket tube, and the top insulator, top attachment and stay tube. The catenary wire is on the top and it is passing through the stay tube via suspension clamp, and the contact wire passes through steady arm fixed on the registration tube. The two wires in regulated OHE is given a tension of 1000 kg each approximately, but the length of our overhead conductors is maximum 1500 for regulated OHE. So for each tension length there is a start and the end. It is taken out of the track and anchored, but before end another tension length is started 3 to 4 span earlier, just like a relay race. Pinto catches the old or previous contact wire, then touches both the contact and catenary wire, then leave the previous contact catenary wire. In this way, our OIT is running from one end to another. That means from east to west and north to south, to continue overhead conductor above the pantograph. This is the system. But for 20 to 25 kV system, another wire is running above the catenary wire, is called feeder wire. Before ending of contact and catenary wire, another contact catenary wire starts 3 to 4 span earlier, and 2 to 3 cantilevers are holding 2 sets of wire. That means 2 set contact and 2 set catenary for overlap. But in the yard there may be 3 cantilevers also for turnout and crossover, everything. In this way, our overhead conductors run on cantilever or cantilevers from north to east, north to south and east to west, to give support of the pantograph above and possibility of current collection. Our OHE conductors for regulated OHE is maximum 1500 meter. In the figure we have shown how we are arranging to run the Pinto under the OHE conductors. In the figure, a previous OHE conductors red in color has terminated on the mast just outside the track, But before terminating the conductors, we have started a new OHE conductors to permit the locomotive pantograph to touch both the wires, then leave the previous one and catch the present one or new one and go ahead. In this way, after every 1500 or less, we are providing this overlap. If this overlap is jumpered, it is called uninsulated overlap for continuity of OHE. But if we need sectioning, we cannot jumper the overlap, but insulator will be provided. As overlap contains two sets of OHE conductors, we are giving 1000 kg each approximately to both contact and catenary wire each, so that in overlap no sag will be there and pantograph can pass smoothly under the two OHs. Figure shows how we are giving 1000 kg each on catenary and contact wire approximately. The system is called auto tensioning device. With the help of a weight, with a mechanical advantage of 1:5, the weight is amplified 5 times and giving tension both the wire catenary and contact wire. Or somewhere the mechanical ratio is 1:3. That means we are giving 665 kg, then it will give around 2000 kg on the OHE conductors. This is the system, because already we have seen that before ending of a tension length or a piece of OHE conductors, we are starting a new one 3 to 4 span RDR. So this overlap zone need tension in all the conductors, so that overhead conductors will not sag and running panto will not entangle with it. ATD means auto tensioning device. It means during hot summer season the copper wire elongates, but if the anchoring is fixed, then it will come down, more sag will come. So to compensate it, we are using auto tensioning device. In the same way, when in winter season the copper conductor contract and the wire become heavy tension, so to maintain the same tension, again this auto tensioning device permits the contraction of the conductor. But how? Figure shows how it has been done. We maintain 2000 kg of tension in both the conductor. From overhead light part and the auto tensioning earth part is insulated by a cut-in insulator. The auto tensioning device, it is the combination of pulleys. One is rotating but fixed in a position and another is rotating and movable to permit the elongation and contraction of the conductor. A balance weight is shown in the picture. In the summer season, the copper conductor elongates and that can be compensated by the balance weight by coming down and maintaining same 2000 kg tension on overhead conductors. In the summer season, the OHE conductors elongate and this elongation is adjusted by the auto tensioning device by downing the balance weight and same 2000 kg tension is maintained. On the other hand, when in winter season the OHE conductors contracts, then the counterweight will raise high and ATT will automatically give 2000 kg to the OHE conductors.